Chapter 15, Statistical Evaluation of Data. As you may know, we have two types of statistics that we use in research. One is descriptive and the other one is inferential. Descriptive statistic is basically a method that we use to organize or to simplify or summarize data, something like percentages or averages or numbers or counting, whatever statistic that we use to describe a set of scores. Inferential statistics, on the other hand, are the methods in which we collect data on a sample and we try to generalize the data to the population. Any number or any score that we collect on a sample or describes a sample is called statistics. So if we have a group of participants and the average score is 25, that 25 is called a statistic. And any value or any score or any score that describes a population is called a parameter. Usually we show the statistic in an English alphabet, and population parameter is shown in Greek's alphabet. For example, here M equals to 25 or S equals to 2, but the parameter is, which is the average of scores in the population, we show it with mu equals to 25, and the standard deviation instead of S we use sigma equals to 2. One of the basic statistics that we use to explain or to describe a sample is frequency distribution. Frequency distribution is simply the frequency of any given score in a sample. For example, in this case, the first column shows the scores, and the second column shows the frequency of that score. In this case, we have one student who got 5 and 3 students who got 4 and 4 students who got 3 on this test. Another way to show descriptive statistics is to use histogram and polygon. Histogram is a graphic version of frequency distribution. Again, this chart shows, for example, how many ones we had, how many twos we had, and how many threes. So for example, here we had 4 students who scored 3 on the test. Or we can show it with a polygon the same way that we use the histogram. And one more way is the bar graph. Bar graph is similar to histogram again, except the histogram is like a continuous numbers, but here we are dealing with categorical scale or nominal scale. So for example, this chart shows how many of the students in the sample were from psychology, how many from biology, how many from English, etc. Sometimes the charts or the histograms easier to interpret, sometimes it's harder to interpret. For example, in this chart you have to figure out what these orange or blue or dark blue and light blue shows in terms of comparing different countries in how the national income is distributed. And this one is another way to show descriptive statistics on how much different countries are different in terms of their transparency. And this is again another one that shows or describes the freedom of internet in different countries. Another descriptive statistic that's very popular is the central tendency. Central tendency simply means the average or the most typical value or the most representative number to show the entire sample. The mean, the median, and the mode are three examples of central tendency. The mean is the average, and the median is the score that divides the distribution in half, and the mode is the most frequent score in the distribution. And finally, another way to describe distribution of scores in a sample is variability that could be shown in terms of a range. That's the difference between minimum and maximum score. The standard deviation, that's the average distance from the mean, and the variance, which is the average squared distance from the mean. This slide shows how actually standard deviation and a variance are calculated. As you see in this slide, these are the scores of the students. This is the mean of the scores, or the average of the scores. So in order to calculate the variance and standard deviation, first you have to calculate the distance of each score from the mean. For example, this is 10, the average is 6, 10 minus 6 is 4, 7 minus 6 is 1, 9 minus 6 is 3. So this is the distance between each score and the mean. So when you make this list, the next column you square them. So this 4 squared is 16, 1 squared is 1, 3 squared is 9, and then you calculate the total of these squared scores, and we call it sum of square. So after you calculate the sum of square, you simply divide it by the number of participants and you get the variance. And when you calculate the square root of the variance, you get the standard deviation. For non-numerical data, obviously we can't calculate the average or the mean or the median or the variance. The only thing we can do is the percentage. For example, you may describe your population in terms of what percentage prefer a Democrat candidate, what percentage prefer Republican candidates.